I welcome you to my next lecture, index properties. In my previous lectures, we have been coming through soil nature in basic interrelationship, and followed by we have solved some of the problems. Now today's class we are going to see about index properties of soils. Properties of the soils. It is playing a very major role. What I mean by property, in the sense, it is a characterization of a particular material. Say in this case it is nothing but a soil. So soil, it is not a solid, so it is made up of solid particles. So it has air, water and solids. So it is a very different material while comparing to other, as I have already taught you in soil nature. Now we are going to learn how to approach the soil. So because soil is not an artificially made particles, it is a natural product. So you cannot control the properties of the soil, but you have to be adjust with the properties of the soil. So properties can be broadly classified into engineering properties and index properties. What is engineering property and what is index property? If you ask, engineering properties are the properties nothing but whatever the property which is involving in the design. For example, you are designing a foundation system for a building. It may be an apartment for residential. It may be G+2, G+3 or G+4 or whatever may be. So whatever may be the superstructure load will be coming to the soil with the help of substructure. So now you want to design a substructure, for example design foundation. So the foundation dimensions are fixed based on the soil characterization. So in that foundation design, it is an engineering design. So likewise, if you want to design a highway or if you want to design a flyover, so in case of flyover, so earthen embankments are there to elevate your embankment to certain level to meet your bridge level. So in this case, earthen embankments are going to be used. So in that case, earthen embankment, earth in the sense, so nothing but soil. So you are going to use soil as a construction material to make up that required volume of embankment. So in these cases, so it is nothing but engineering designs. So if you want to incorporate your properties, I mean soil characterization there, that is nothing but engineering properties. What are index properties? Index properties are nothing but indicative to the engineering properties, which means, for example, I wanted to design a foundation and soil is nothing but just like a sponge. If you apply load, it is going to settle. If you apply load, the sponge is going to settle. Now we want to characterize the compressibility of the soil behavior. So we have to do a test called odometer test or consolidometer test. So in that test may take 7 days time to complete to understand the property of compressibility. At the end you get coefficient of consolidation or volume compressibility, like that. So those are the engineering properties, but that will take too much time and it is difficult to 7 days. So during the 7 days you should not touch the equipment. So in that undisturbed mode you have to conduct the test for 7 days. It will be very difficult to conduct, but we have some properties so which can talk about those engineering properties, say compressibility or permeability or shear strength. So those are the engineering properties. So we have index properties that can describe the probably what may be the value of engineering property that we can decide. So with that introduction, so I am going into the index properties. So index properties, I can list out water content, specific gravity, particle size distribution, density and relative density and consistency limits. So these are the index properties that is going to be discussed in this lecture. So now, so does index properties. So one by one we can see. So first one is water content, specific gravity, second one is specific gravity, third one is density, and fourth one relative density, fifth one particle size distribution, and sixth one consistency limits. So likewise we have index properties. So let me going in one by one. So first thing is water content. So if you are collecting a sample from a site, so it is always represented by a ground level. So the symbol represents ground level, so GL. So I am collecting a sample anywhere like this. So I am going to place my foundation at this level, say 1.5 meter. So we have to analyze this particular strata which is going to take care of your superstructure load. So you have to collect this sample. So you are collecting this sample and taking into your laboratory, or we have some of the field tests also which can directly give your water content value. So what this water content can do over your design, in the sense this water content, say some of the moisture, as you know, in three-phase diagram, air, water and solids, if water proportion is going to high, the entire behavior of these particular soil strata may change. So as I have already described, cohesive soils, so this cohesive soils nature is going to change when water content is increases, it is going to be lose its cohesive nature. So that is the thing. So that is why we are analyzing the water content value. So it is represented by the symbol W. So W is given by weight of water to the weight of dry solids presence. So R, mass of water to the mass of dry soil. So you are taking it into the laboratory. So initially you are taking a mass of the particular sample. Say this is a mass M1, it contains air plus water also. Now you are making it too dry in some other way, we will be discussing that. So at the end you get dry sample M2. So M1 minus M2 will give you mass of water. So this is a wet sample mass and this is a dry sample mass. So wet sample minus dry sample, you will be getting mass of water present. So divided by mass of dry, or MS it can be also represent. So if you multiplying this 100 in terms of percentage, you will be getting the answer. So that is a simple thing. So mass of wet minus mass of dry, you will be getting the mass present. So at the site for this dry soil will be the water content. It is very easy. So we have some other methods. So we will be discussing this very shortly. Oven drying method. So oven drying method is nothing but we have a very large size hot air oven. We will be having a slab like this in like steel messes. So you are keeping your samples in a very small container, say 10 grams or 20 grams may be enough to this. You are keeping your wet sample into this 20 grams of wet sample into this container and keeping in this oven for 24 hours. So 24 hours is a matter, 24 hours, and 110 degrees Celsius must be kept maintained for this for 24 hours. If it is containing any organic matter, it has to be reduced to 60 degrees Celsius. So it won't burn. Organic soil, organic content won't burn. So or any there is absence of organic content, you have to maintain 110 degrees Celsius for 24 hours. So it is given by IS 2720 Indian standards. We have up to part 1 to 41 totally. So we have different tests. So all these comes will be in part 1 to 41 in IS 2720. According to that I am talking. So 60 degrees Celsius has to be maintained for organic soil, 110 degrees Celsius for normal soils. So at the end of the day, I mean at the end of the 24 hours, you will be getting the answer. So M2. Pycnometer method. Pycnometer method I will be discussing in the next topic. It is very easy only. Torch and balance method. What is torch and balance method? We have a disc like this. At center it is a deformed shape. So and it is positioned with the help of a pivot, just like a needle, and you are taking a little 5 grams to 10 grams of soil and pouring that over this surface of the plate, and this needle is likely to going down when you add soil. So there is no need of weighing this 5 grams before that. So it is going down, and by mechanically it is attached to a graduation circle that is showing moisture content. Initially you are fixing it as 0 once it is loaded, and it is in closed container, and there is a lamp which is giving an infrared waves over the sample. Because of this heat developed, it will be evaporated, and this needle is likely to going up because the weight got reduced, and this is in balance. So like a torch and balance method, a spring attachment, it is going upward and it is showing some other reading. At the end, say after 10 minutes, you will be getting a reading, direct reading of 5% or 6% like that. So it has to be corrected further. How it has to be corrected? Water content m divided by 1 minus m. So moisture is an if answer, so it has to be corrected like this. So it is nothing but a torsion balance method. Alcohol method. What is alcohol method? So it is nothing but you are taking a sample, say 20 grams or whatever may be, you have to weigh it. Initially you have to weigh it. So wet sample, and you are taking a tray like this, and you are putting this M1 as a known M1, and you are adding alcohol. You are adding alcohol and just burning it. Once you have got burning it, because of the flame, the temperature rises and water got escaped. So at the end, you will be taking the mass dry, so as M2, so divided by mass dry, you will be getting the answer. It is a very simple method and it is taking lesser time, but it is not accurate. Next thing is the radiation method. What is radiation method? In the sense, so there is an consider the scenario like this. So here it is an emitter, here it is an receiver, emitter. So the emitter will release neutrons. So Gopal 60. So Gopal 60 capsule is placed, so in this hole, so there is a borehole setup. So in this hole you are fixing Gopal 60 capsule, and this will be emitting neutron rays, and there is an receiver at a short distance. So this receiver will receive the neutrons. So the density or concentration of neutron got released in this emitter is measurable, and the receiver receives the density of neutrons is also measurable. So while comparing this two density or concentrations of neutrons, we can compute the moisture content present. How? So the moisture may present in this pores got scattering the neutrons. So these molecules can scatter the neutrons, so lesser density or concentrated neutrons only will reach this receiver. So this difference can notify the moisture present. So that is radiation method. Sand bath method. Sand bath method, say for example you are taking a tray like this and fill 3 cm of sand. 3 cm of sand has to be filled, and any glassware, taking a glassware and filling wet sample, say M2 as known volume, and you are add a paper, white paper, kept it in this sand, and you are start burning. So it is flame coming. If you start burning, if you start heating the tray, that is in a steel tray, and now the temperature has to be maintained at the limit of this paper should not get brown color. So that is the heat you have to control here. So this is a control setup, and this white paper should not get brown color, and this has got heated. So because of this heat, so it will loss the moisture got evaporated. So at the final you will be getting M2. So M1 minus M2 as explained same, you get moisture content value. Calcium carbide method. Calcium carbide method, it is nothing but CaC2. What will CaC2 do, sir? CaC2 plus 2H2O. So we'll be giving C2H2 plus CaOH twice. So there are 4 H's, so 2 H's and 2 H's will gone, and 2 O's will be placing here. So calcium carbide is like a salt. If you add in soil, it will be going to react with water and forming C2H2 is nothing but acetylene gas, and this byproduct CaOH twice is an calcium hydroxide. So this C2H2 is nothing but an acetylene gas that is going to fill the place. So it is an closed setup. You are going to place this, add the salt. Once it got reacted with this, it will be releasing the C2H2 gas, acetylene gas. So this acetylene gas, by measuring this acetylene gas by means of pressure, so we can judge the amount of water present in the wet sample. So it is also like a torsion balance method. So we have to do this correction, very simple correction. So by this very simple methods, we are coming to conclude the water content method. So while discussing this, so we have about 7 methods. Oven drying method is an 24 hours method, but other all the 6 methods are consuming very lesser time comparing this, but this is very accurate method as followed in IS 2720, which is the very rapid method. Is calcium carbonate method is very rapid method. Then sand bath method will around take 60 minutes to complete. So radiation method is also an rapid method. It is conducted directly in the field. So alcohol method, torsion balance method and pycnometer. So all these methods are relatively rapid. So calcium carbonate method is very rapid test. So but this is consuming more time. It is consuming 24 hours of time, but it is a very accurate method. So all these methods are not accurate. So this is very accurate method. Next, while coming to specific gravity, so specific gravity is a very easy test. So this is for coarse grained soils, and this is for fine grained soils. Now I am going to explain. So all these things, density bottle, measuring flask and glass jar method are same, including pycnometer, all are following the same methods to find the specific gravity value. So what is specific gravity? Is density of solids to the density of water. So it is nothing but a ratio of density of water as a considering as a standard material to the density of solids. So how much the gravity influence may playing role on solids while comparing to the standard material called water. So it can be also rewritten. So mass of solids to the mass of water, which is occupying the same volume, if the same volume of water may give mass of water. So if you replace this same volume of water with solids, not soil, if you replace it with solids, you get specific gravity of solids. So this can be ideally given by the experiments. So this is nothing but a pycnometer. We have a cone shaped cover at the top, and this is nothing but glassware. So M1, M2, M3, M4 we have. So what is M1? M1 is nothing but empty. So it is empty pycnometer. M2, it is nothing but 1/3 dry soil. 1/3 dry soil is filled. In M3, it is a mass of empty pycnometer. It is a mass of empty pycnometer with 1/3 dry soil filled. It is a mass of 1/3 dry soil added with water. So up to this cone top, so it is also filled. So up to this cone top, it is filled. So here only water. So these are the mass configurations. So M1, M2, M3 and M4 as described empty, 1/3 dry with water alone. So we get how to calculate specific gravity G. So as I already discussed, mass of solids you wanted to find and mass of water which is occupying the same volume of water has to be find out. So now coming to this formula, so let me explain with this. So volume of solids, so likewise, so as explained earlier, mass of solids to the mass of water which is going to be occupied with the volume of solids. So if we consider volume of solids, so what is the respective weight, which if it is occupied by solids, what is the respective mass if it is occupied by mass of water. So I can give a clear idea about this. So once M4 minus M1, will be giving this. So this empty weight, we are minusing the empty weight, you will be getting M4 minus M1. So full water plus mass of jar, empty. So full water, mass of jar. While minusing this, you will be getting mass of this water. You will be getting mass of this water, and this term explains M3 minus M2. So this is soil including water. If you are minus this soil, you will be getting mass of water which is occupying the volume except volume of solids volume. So once you minus this with the total mass of water, you will be getting the amount of water in terms of mass which is occupied in volume of solids. So that is very simple. So M2 minus M1 divided by this thing, you will be getting the specific gravity value G. So remaining test is picnometer test. It is nothing but this. This is picnometer jar. So density bottle, it will so by the shape, it all these methods are varying. By the shape only it is varying, but the concept is same. Shrinkage limit I will be explaining in the later part. Now while coming to this density, it is very interesting thing. So it is in ground level. So what is then? So we have in different stratas like this, strata 1, strata 2 and strata 3, strata 4. Likewise it is keep on going. Now so this strata may be changing. While going deeper, the pressure got increases because of the overburden pressure of 1, 2, 3. So fourth one is carrying all the weight of these 3 layers. So it may be denser, it may be lesser denser, it may be lesser denser. So like that it is an ascending order while going down. So density is represented by the symbol rho. So it is nothing but mass by volume. So it is playing very major role while discussing about the compaction and denseness. So this is a very important parameter, denseness. How much it is dense, it is talked to density, especially dry density. So a particular strata, to talk about a particular strata about its denseness, so this dry density is an only way. Now we have a simple formula, rho equals to mass by volume, as we have already discussed. So we have a method called core cutter. So at the surface, wherever you want to find a strata or at any level, so you have to be excavated that, and you are playing in core cutter. It is nothing but an empty hollow cylinder, and you have an hammer going to give an impact over this core cutter. Once you are giving impacts while getting upside and dropping it over the hammer, it will be going in, so like penetrating this, and once it is got penetrated, you have to excavate this, I mean slightly excavating this surrounding by digging it, and you can take it outside. Once you take it outside, it has to be sealed with wax, because it may contain any moisture, say water content, it may contain any moisture, and it is waxed because water should not be evaporated. So once it is waxed completely, it got sealed. Because of any temperature variation, it won't go down, it won't release, so moisture will not be released. So like this, it is taken into the laboratory. So you get wet sample weight, so divided by, so this is it is a cylinder known with a known volume, so wet sample weight divided by volume, you get wet density. So as you know, dry density is wet divided by 1 plus W, you get dry density value. This can be talked about denseness. So next method is a sand replacement method. So we have an sand pouring cylinder with open and shut, so it will be like this, and we have an calibrating container like this. So and there is an tray with a hole. So going to using this, you can simply find the density of the particular strata. So it is very simple how to find this. So mass by density. So this, it is a tray with a hole at center, it has a hole. It is going to be placed over here, soil sample at the surface ground level, and you are digging it and taking out the mass, and you are just keeping inside this tray only. So why we are skipping this core cutter means, while giving impact over this core cutter, so if there is any rock or broken stones, it cannot be penetrated. Or if it is very loose, while taking this core cutter out, so the sample will be spilling away. So that is why we are going to this sand reflex method. So it has limitation. So because of that limitation, we are going for sand reflex method. So as explained, so we are taking out the soil sample and keeping in. So in this tray, so density is nothing but mass by volume. Here, mass of this sample taken out has found in the laboratory, but volume of the whole, so let us take VH. So volume of the whole cannot be found easily. So what to do? So we are going to use these tools. So very simply, so you are taking this, say it is initially filled with sand, say M1, and we have a cone set up here. So open set, so we have a cone here. So this is sand pouring cylinder SPC. So this is calibrating container CC. So we are placing this over this calibrating container CC. What do we do is, so initially it is filled with fully sand and taken weight as M1. Once we release this, it is like filling as sand timer. So it is got finally filled. Now you have to shut the door, it won't fill anyway, and taking this and weighing it to M2, you get, so M1 minus M2 is nothing but it is filled, okay, it is giving, so M1 minus M2 will be giving the mass of sand in the calibrating container. So mass of sand at cone, so at cone also you are giving, so it will be projected outside, so you have to spill this sand into a paper or any tray, and weighing this you will be getting this value, mass of sand at cone, you will be getting this mass of sand at cone. And if you minus this from M1 minus M2 value, you will be getting mass of this, sand present in this cone shaped. Now density of the sand is nothing but, so this mass is nothing but this mass divided by, that is a regular shape, volume pi r square h. If you substitute, you will be getting the density of the sand. So with this help of known density of the sand, you are going to use to our benefit. So how to use this our benefit? So as excavated here, so volume of hole as a question mark, still it is a question mark. So what you are going to do now, so there is an irregular shape of hole, and you are placing your cylinder here and you are opening it. So likewise it is keep on filling, and it is keep on filling up to this level, it is got filled. So same M1 minus M2, but in this case M1 is the same, but M2 is definitely going to be different one, because it is an irregular shape, it may consume more sand. So this may be then lesser value, while minusing this will be higher value comparing this. So now minus this mass of sand at cone, so minusing this, you will be getting the mass of sand occupied this hole. So the final, so mass of sand at hole you will be getting. Now as you know the density, say the value is 2.1 gram per cc. So density, substituting this mass at hole divided by volume of hole as an unknown. So this is known at the end of the weighing balance results. So volume of hole can be found out, and this is going to be substituted in this volume of hole. You will be getting the final answer as a density. So very simple thing. So it has Korteka's limitation. To overcome this limitation, we are using sand replacement method, very simple one. Water displacement method, radiation method and rubber methods are the very simple methods, like same sand replacement methods. Water displacement method is nothing but, so any irregular shape of soil has got waxed, got sealed, and you are putting in that in water. So this equivalent volume of water got spilled. So you get to know the volume of this irregular shape. Once it is an regular shape, you can easily find the volume, but it is an irregular shape, the volume of water got spilled. Using that you are finding this value, very simple. So radiation method, so as explained in water content radiation method, so here gamma rays are passing, so same emitter and receiver. So by the concentration of gamma rays at the receiver, with this difference you can find the density value, very simple. So rubber balloon method, so we have a hole here, and you are keeping an balloon and it is filled with air. Now what we do, it is while giving air, it has got the safeguarding changing, and it is almost filled by its surface, by its skin, it is almost filling, so all the hole, and once it is got filled, you are arresting this, and while taking out, and what is an volume of air present in this balloon represents the volume of this hole, so it can be directly substituted here, very simple. So this is how we are coming through water content, specific gravity and density. So what is relative density is a very simple thing to talk about it. So density, so this is our relatively little bit same concepts. Density is nothing but, so what is an volume mass of the soil which is occupied in the known volume. But in this case, relative density, for example, you are taking a vessel full of sand, say now it is at loose state. If you give some vibrations, what happens? The volume got decreases, which means particle got rearranged. So the particle got rearranged and it is got settled somehow. Now it may be in a medium state, then you are giving more vibration, it is further going down, now it has become very dense. So initially it is very loose, after giving some particle disturbance it is going to medium, then dense. So these are the different states. So while describing this different states is nothing but relative density. So I can give you this. So a soil can be very loose like this, so the same soil can be very dense like this. So between this range, so between this very lower limit to upper limit range, so what is the present state of your soil? That is nothing but relative density. So relative means you comparing. So comparing with this range, so what is the present state is nothing but relative density. So E max represents loosest state, E minimum represents, because it is in void ratio, so voids are very lesser in dense state, so it is E minimum value and E max value. So E max minus E minimum will give you the range, so divided by, so that is the range at denominator. So E max minus, it is E natural. So E max minus E natural, say this is in present state, E natural. So E max minus E natural, you will be getting some value. So this can give you the relative density, how much it is compacted. So is an value. So here it is natural, here it is minimum. So what is an value towards the denseness? It is a value for how much. So we will be getting this. So I am rereading this, E natural minus E minimum. So that is the thing has to be in numerator. So at the end of this today's session, I am finishing with index properties. So still we have particle size distribution and consistency limits. We will be seeing that in my next lecture. Thank you.